We will be starting in about 2 minutes. Thank you.
Good evening, dear colleagues, and welcome to our side event on South-South cooperation for atoms for food. I'm Yulia Vistavna from International Atomic Energy Agency. I will moderate this event. We know all climate change has no border. Its impact both developing and developed countries, and particularly impacting different economic sectors, including agriculture. We know that now we need more and more methods, we need innovation, we need new approach to address these challenges. Today in our session, in our discussion, we will address different case studies, how we use innovation methods, including nuclear techniques, to address challenges related to agriculture. Please let me to introduce our panel today. We have Dr. Francesca Carvara, Italian Special Envoy for Climate Change, Dr. Sayed Haider, Deputy Chief Scientist, Nuclear Institute for Agriculture and Biology, Pakistan. We have Sadiko Lota Lazar from Global Climate Change Alliance Plus from African Union, and Martin Krause, our... It's not working, microphone. Martin... Yeah. And Martin Krause, Director of Technical Cooperation, International Atomic Energy Agency. So our session today, it will be the panel discussion with a range of different questions. So please me start from the first question. What I would like to pose to Mr. Sadihi from African Union. Please, how is Southern Africa vulnerable to climate change? And what challenges does it pose to food security?
Thank you so much, colleague, for starting with African Union. Actually, African region or African continent strives to combat climate change, and it strives through to increase agricultural productivity, to enhance food security, while striving to ensure that natural resources and environment is actually sustainably utilized. As we all recall, about 85% of the African continent is dependent on to natural resources, and of course agriculture itself is dependent onto the rain-fed agriculture, which is mainly affected by the impacts of climate change. This include, of course, the rise in temperatures, which has much impact into the productivity through the increased diseases to both crops and livestock. And of course, with the low technology in the region, then agriculture becomes more vulnerable on these climatic condition. Again, 65% of the region is actually dependent onto the subsistence agriculture, of which again is impacted by the climate change across the globe. And in this case, and this panel discussion today is quite important for the region, since it is bringing on board the atom for food aspects, which it brings on board the nuclear aspect, will really be important in the region to really curb all these challenges through bringing on the precise technology, which of course, while it is quite required in the region, there is still much more to be done in order to enhance the productivity of agriculture and of course enhance the food system and security in the region.
Thank you very much for highlighting those challenges. I believe those challenges not only have regional aspect, but many other countries and globally also experience them and now under the changing climate. Also, thank you for highlighting nuclear methods and technique that can be applied in this case to improve the situation. My next question goes to Professor Carvara. Professor Carvara, agri-food systems play important role in the context of climate adaptation efforts. Could you please share some insights and perspectives, but also maybe to tell us a little bit more about challenges and solutions what agri-food systems are facing given the increasingly uncertain climate condition, as also been mentioned before. Thank you.
Thanks for the invitation, first of all. Yes, as you said, the connection between food security and climate is really strong. Italy is working a lot on this direction. Think about that the Mattei plan that we have for Africa has a pillar completely dedicated to food security, and the Italian government decided to design a special envoy also for food security. Why this? Because one of the consequences of climate change is the land degradation. And connecting with the land degradation, we have scarcity of food, scarcity of water. And normally you think that this is something that affects only the developing countries. Instead, there is some big issues and consequences of this that invest also the developed country. One of these is the migration, or as we call this, is the climate mobility, but climate mobility is migration. We launched in this COP on Friday, last Friday, an initiative that is called Climate and Peace, with the presence of COP29, and inside there is a pillar dedicated to food security. Because from my perspective, food security and water scarcity are the main consequences that create tensions among different countries, migration and conflicts. Normally, we try the newspaper, you can see a lot of news about conflicts in Ukraine, conflict in the Middle East, and so on. But there are a huge amount of conflicts around the world for climate issue. So if we are not able to support the food security system, the agricultural system, using different techniques like the one that is connected with nuclear, it is impossible to think about the climate change. And this is an adaptation that is necessary right now, because climate change is right now. So it's not possible to postpone this kind of solution. Italy has several projects. I had the possibility to went to Mauritania, and I saw there are some concrete project to give to the population the possibility to restore their land. And I spoke with them in a region that is close to Mali, and Mali is a big issue right now in the Sahel. And speaking with them, they said me, we don't want to quit. We don't want to stay in our land. We have no idea to migrate to another country and to come to Italy. Obviously, if I don't have enough food for my daughters, for my sons, I need to find a solution. So they want to remain there, and it's duty of some developed country like Italy to support this, because this is a benefit not only for them but also for Italy, that have the possibility to control a big phenomenon like the migration.
Thank you very much. I was thinking also when we will start to have climate migration. So we already actually have it now, and it's also very important to consider what it's another confirmation. What climate change, it has no borders, so it's impacting both developing and developed countries. So even we are facing now with climate migration, probably it can be enhanced and maybe stronger. So that is what we need to act now, to develop new methods, new techniques to reduce this, because movement, it's also, we know it's not easy. This is another stress for the population, for society, for environment. Thank you for this important highlight, and I would like to ask about innovation and new methods. But maybe it's already not new method, as everyone mentioned it, because of nuclear techniques used in agriculture. Martin, for some people in audience, actually it might be very strange to connect food and atoms, because the International Atomic Energy Agency is very known for mostly for nuclear security, for nuclear plants, and it's less known in terms of food and agriculture. How can nuclear techniques help to address the challenges of food insecurity and changing climate, what been previously mentioned by Professor Carvara and Mr. Sadihi?
Yeah, thank you very much, Julia. You're right. If you mention nuclear in one sentence together with food, many people are afraid, because nuclear is perceived as a, let's say, a pollution or a threat to our systems, right? Our ecosystems, our body. And if you say food and nuclear, that doesn't go well together in the perception of many people. Now here we are talking about, food insecurity that is being accelerated by climate change. And the special envoy from Italy, our colleague here, has already alluded to it. The economic and social problems that it brings with it in its wake are enormous. So if we look at food security or food insecurity, or of more robust agro-food systems, we from the International Atomic Energy Agency, we also make a contribution in this arena. And I want to explain this a little bit, because, as I said at the beginning, it is not so obvious for many people. I give you some examples. Crops are mutating. It's a natural occurrence. There is natural mutation. It happens over long periods of times. Mutation breeding is a technique to accelerate the naturally occurring mutation in plants. So we are using that technique to help farmers to generate crops that can withstand drought, storms, flooding, adverse climatic conditions. We have examples, and maybe my colleague will talk about that as well from Pakistan. We have examples in Bangladesh, for example. Rice varieties that have been using the mutation breeding technology to generate rice varieties that are drought resilient, that are flood resilient, that can deal with saline soil conditions, in those coastal areas. So the mutation breeding is one of those technologies. Another one is the sterile insect technique. Sterile insect technique is a technology to sterilize the male insect, and then they are being released into the wild, and they cannot produce offspring. So we have been using that technology in a number of countries, fruit flies, for example, and that helps with the pest control, because with a warmer climate, the problem for crops is often, and also for animals, is to control the pests. And you can use chemical fertilizers or all kind of environmentally damaging methods, or you can use the sterile insect technique. And that is another example of where a nuclear technology can complement traditional, let's say, techniques and methodologies on how to deal with a particular problem when it comes to pest control. So these are just two examples of where we believe those new innovative nuclear techniques and technologies can make a contribution to the overall agenda of creating more food security in the context of climatic changes.
Thank you very much. So generally we have discussed previously challenges what we have. So nuclear techniques can give us some a wave of optimism in this direction. Particularly we have this floods, droughts, growing temperature. But if we are properly using different technology what is available now, we can change the situation, yes? And I would like now to ask a question of Dr. Sayad. Dr. Sayad, what has been the impact of mutation breeding? What is actually mutation breeding now? I understand what it's mean. Before I don't know what exactly mean it, but now it's much more clear. In Pakistan, how you had success with a particular crop?
Thank you very much. First of all, I appreciate the organizers of this event. This is a very important event of important event for a very broad spectrum collaboration. In Pakistan, there is a very active collaborator of IAEA, FAO programs, and with these collaborations, Pakistan has successfully implemented and used these new mutation techniques. As you know, Pakistan has in its different regions, 4-5 regions, diverse in their climatic conditions. We have plains, we have mountains, we have coastal areas, we have a temperature which is in hot conditions 30 degrees centigrade. We have a temperature in the same duration it is 48 degrees centigrade. So there is a diverse climatic conditions in Pakistan, and under these to cope with the other techniques, we have utilized nuclear techniques, and we have established different institutions which are working on different aspects in different climatic zones with the collaboration of IAEA. Now, using these nuclear, this is a very simple technique. It's a very complex technique. Mutation breeding is simply, as I already informed, that just to irradiate the seeds, to create variability, and then its utilization, then its selection, and then its checking its stability. And similarly, there are other ways of induced mutations. Mutations are just to create variability. They are not hazardous in any way to the crops, to the human health, to the plants. Even new mutations, radiations are used for even human health as well, very successfully. So in using these techniques, we have 4 different centers in different zones. And by utilizing this mutation breeding techniques, we have developed 157 mutant varieties. And if you check the IAEA programs, this is a number of thousands of mutant varieties developed all over the world. In Pakistan, we have developed 157 mutant varieties of different crops, which including cotton, rice, wheat, pulses, mung beans, sesame, castor oils, oil seeds, and so many crops. These are climatically adaptive to different zones. So these, by using these mutants, we have developed mutants which have in different zones have very good acclimatization, adaptability, and they are producing high yielding, tolerant to heat, tolerant to stress, tolerant to salinity environments, and they are very successfully grown. I can't say that 157 all mutants are performing very well, but some of the mutants, they have performed excellently well. I will give you a few examples. One of our cotton variety, NAB 78, this was developed in 1983, and it has been successfully grown up to 1994. Its lifespan is very active in almost 15-16 years, and its performance is excellent. And it has covered up to 40 to 60% area all over Pakistan, especially in the cotton growing zones. Same is the example of pulses crop, mung bean crops. this mung bean crop was not a traditional crop in our climatic conditions, but there was another sort of pulse, but it was used for animal feeds and for other poultry purposes. But we have irradiated and utilized a different species of that variant and irradiate them and selection. And we have developed 16 mutant varieties in which 4 or 5 varieties are performed so excellently that it has developed a niche in our Punjab province. In 4 or 5 districts, it is planted on 60 to 70% area. And we are now self-sufficient in mung bean pulse crop. And if you visited the IAEA laboratory, they have given example of mung bean crop, specifically with the name of Pakistan. So similarly, for different crops, rice, we have developed mutants. Especially our Sindh province, we have developed very wheat mutants. So these are very successful examples in Pakistan, including there are a lot of examples in other countries as well. I am specifically talking about Pakistan. So by introducing this mutation breeding technique, we are utilizing different other techniques as well. We have a program of specific this induced mutation, and we have successfully developed mutants which have contributed to our national economy, even to sustain food security. Even the mutants are very resilient to climatic conditions. We have very erratic, different types of environments. We have problem of sometimes we have very extensive rains, sometimes we have very low rains, sometimes we have temperature 50 degrees centigrade, sometimes we have temperature 30 degrees centigrade. In different zones, we have successfully utilized these mutants, and for wheat, pulses, even for cotton, we have got very good results for these mutants. Thank you.
Thank you very much for showing us the case of Pakistan. So generally we discuss what we have different climate-related challenges. We have temperature growing. We have also temperature changes in terms of lower and higher temperature frequencies change. We have precipitation also change. We have floods, we have droughts. We also have migration now due to the land degradation. So generally we have these challenges from one side. From another side, we already have some positive movement towards the smart agriculture. The agriculture is able to adapt to those changes to reduce the migration in this case, and this is thanks to different tools, including the nuclear method, what we discussed now. Yes, but from other side we have technology and challenges, but also we have people. Yes, we have people at the local level, we have people regional cooperation, we have people international cooperation. So how cooperation is important? I would like now to turn our discussion how cooperation can facilitate the introduction of technology, implication of technology to better assess also challenges to what we need to adapt. And I would like to ask Martin. Martin, please can you tell us how, so we heard about all this change, but how using especially South-South cooperation we can support countries. What is behind their current International Atomic Energy Agency and Food and Agriculture Organization Atoms for Climate initiatives?
Thank you, Julia, again for this question. I think over the last couple of years or decades, in the development community, we have learned that the top-down approach is not really working. We need to embrace a different type of approach of cooperation. And that approach, we call it South-South or triangular cooperation. And what does that mean? That means we have to learn from each other. And I want to go back to the example of Pakistan. Our colleague here has described some of the initiatives from Pakistan to create mutant crops. And don't be afraid, that sounds like from a science fiction movie. It's not. It is, as was explained, it is just accelerating a natural process to help to adapt certain crops to adverse climatic conditions. Now, Pakistan has engaged for a long time with us, with the IAEA, in building the capacity in the various research centers, universities in Pakistan on those nuclear techniques. Now, Pakistan has become kind of a knowledge hub almost on how to do this. And Pakistan now is teaching other countries. They are coming to Pakistan to learn and to build their capacity. And not only from the neighboring region, they're coming from Africa. They are coming, I believe, even from the Caribbean or from Latin America you had. And that is what we call the South-South. So the colleagues from research centers from Africa are going to Pakistan to learn about those techniques that we have been discussing here. That is a very powerful example of what we call the South-South cooperation. Triangular means that another agency or country comes in, for example, the IAEA. We help through the technical cooperation program to make that happen. We offer grants for workshops, for capacity building seminars, for scholarships, to make it also financially, possible for those that need to travel from Africa to Pakistan to learn for 2 or 3 or 4 weeks on how to do that. So that is a powerful instrument that we have at our disposal and that we are deploying more and more. We have in the IAEA also the so-called regional agreements. And a regional agreement means that the countries in Asia have signed up for working together on building up their knowledge on these nuclear techniques and technologies. And we from the IAEA, we are facilitating that process. So we have institutionalized, if you want, at a regional level, the country-to-country, South-South cooperation. And that is another very powerful way of doing that. I will give you one more example. This is from Africa on a program in which we have been engaged for the last more than 10 years, and is in the Sahel. The Sahel, as you all know, is a very dry region, and that is particularly vulnerable to climatic changes. And they have a large underground water resource in the Sahel. But nobody knows exactly how much water is underground, what is the volume of reservoirs that are hidden, that you cannot see, what is the replenishment rate of that underground water, what is the age of that water. So there are a lot of questions, around that, and how, of course, can you use it, pump it up through wells for irrigation in the Sahel. So we have been working with 13 countries in the Sahel for over 10 years to do a mapping of the underground water resources. And now the 13 countries are sharing their data sets, because underground water is transboundary by nature, obviously, right? So they are sharing their data sets, they are working with each other, 13 countries, facilitated by IAEA Technical Cooperation Program, to get a better understanding of what precious resource, freshwater resource, they have underground, and that can inform then the agricultural policy making. Where to dig the well and where not to dig the well. Very simple, right? That's another example that I wanted to bring. Yeah, so Atoms4Food. Let me just continue if I have 2 more minutes. Atoms4Food was mentioned. Atoms4Food is a new initiative that is only about a year old, a year and a half maybe. It's a joint initiative from the FAO and the IAEA, so the Food and Agricultural Organization of the United Nations, and our organization. It was jointly created to address the problem of food insecurity, and not to address it only, from a narrow perspective, but to bring in technologies, innovations, and in a more holistic approach. So what is it all about? It is member states, countries that are requiring assistance in this field. They can come to us. Us means the FAO and the IAEA, and they can request support to assess or to map where is an added advantage and value for the FAO and the IAEA to come in and support. You know, there are many agencies and many initiatives happening from NGOs, from the international finance institutions, from, of course, the national governments in many countries. They have their own initiatives. So we need to figure out where is a value added for the FAO and the IAEA to come in and to support those national agencies, stakeholders, government entities, research institutions, and so on, that are dealing with food insecurity. And based on that initial assessment, we offer certain services. We offer grant funding for particular projects that are needed within the context of the agricultural setting in that particular country. And that can be requested through the Technical Cooperation Program or through a CRP, a coordinated research program that the agency, the IAEA, also is doing, as you know, Julia, in many countries and regions. So there are opportunities for those who want to join the Atoms4Food initiative to access resources, both financial and intellectual and technical resources from these two agencies.
Thank you very much for highlighting all that. And please let me to add something a little bit more about Sahel region, because recently I've been in the Sahel region exactly by this subject. And there is a Lake Chad. We know about Lake Chad. It's one of the largest lakes in the Sahel. And if we go to the more to the desert area, it was found people there, paleo people. So it means what it was life there. So it means what there is an underground paleo lake, what we are trying to study now, it exists. So it's not, that is why people been living there, because it was the water. Because people never live without water, because we need water for irrigation, for growing the food. So probably it was one of the first climate migration what we can trace, but people need to move more to the south of the region, because Lake Chad, the decrease. But there is a water reservoir with different age, what we have, what we're trying to discover, because it is not very easy as it is invisible source of water. And it has different age. Different age, it means there is a water of 1 to 10, 100,000 years. And it means if you are using water of 1,000 years for irrigation, for food production, you need 1,000 years to replenish also that. But this is one of the important things to connect in water generally and agriculture, what we should consider. And to continue just with subject, because you mentioned also the Pakistan cooperation. In that time of paleo lake in Chad and paleo people in Chad, they didn't have technology, they didn't have innovation. But another thing was they didn't have, they cannot cooperate easily between each other, because or it was nomad or it was isolated communities. Now we have all these tools in our area in community. And you mentioned the successful example of Pakistan. And I would like to ask Dr. Sayat, could you please give us more example about this cooperative efforts and work, what Martin mentioned, and particularly what lessons learned, what can you share with us, what can be used for other example for other type of cooperation?
As I already Mr. Martin had informed, that in 2023, IAEA declared one of our institute, NIAB, which is located in our Punjab province, as a collaborating center. And this was inaugurated by Director General of IAEA in previous year. This center is a type of collaborating center which provides technical expertise, technical know-how up to a limited period of time. I will give you example that during almost 1 year, we have got trained almost 38 participants from almost 17 countries. And these were, I am giving figures, these were of short trainings. And similarly, there are 2 to 3 months fellowships as well. In this regard, we have also trained, I think, up to 7 to 8 countries, researchers which visited our country, and we have given whatsoever we can train them in limited 2 to 3 months. So this is a very unique example of collaboration. Even in a medical grounds, we have also IA declared a collaborating center, where we utilized this irradiation techniques for cancer treatments and so many other aspects. We are also collaborating with IAEA and international world for giving opportunities to train those people as well. So this is specifically from agriculture point of view, from food security point of view, from climatic diversity point of view, we are very well trained manpower in our 4 centers, which are located in different climatic conditions, and we are providing accordingly training to those people. Similarly, if we look at cooperation example, in previous 2 to 3 decades, we have collaboratively with IAEA and FAO, we have got different collaborative projects which are of ROS nature, and there are so many CRPs type, and I think this figure is almost 47 different types of projects in previous 2 to 3 years. So we have very strong collaboration, we have expertise, we have manpower, we have very big opportunity to train those people which are wherever in the world. We can train them, and we also assure all participants and the utilization of this technique is a very effective. This is a very almost there is no hazardous point of view in this technique. This is utilized this can be utilized very effectively for security, food security, and to develop resilience in different plants to the different climatic conditions. So now there is another aspect is of resources. There are a lot of Atom4 atom. There are different collaborating partners in this era. These are collaborating in some or other way. Some institution may provide technical support, some institution may provide financial support. So there is a very big opportunity in this era. We can collaborate for national, international food security, and to develop the crops, the plants, the fruits, the vegetables, the planting trees that can sustain this erratic climatic conditions in all over the world. So this is a initiative, very useful initiative, and I hope and I believe that it will be, inshallah, successful initiative. Thank you.
Thank you for highlighting experience of Pakistan and South-South cooperation, because in all initiative, as we understand, we also have lessons learned, problems what we can address, gaps, but there is always an opportunity to link people and to work on the same problem and to share the experience and to improve the situation with the technologies. And thank you, and I would like to now to ask Professor Karvara. We just mentioned about different type of the support, and why is international support for food security important, and how Italy support also other countries what have agri-food system most vulnerable in the world?
So, as I told, climate change is has the big connection with food security, and as you mentioned in the beginning, climate change has no barrier, no borders. For this reason, the international cooperation is crucial. Without a good and power international cooperation, is not possible to really fight against climate change and find solutions. For this reason, I believe that it is crucial to engage and to improve this relationship, and Italy is doing this with a specific program. I mentioned the Mattei plan, but it's only one of the plan that we have. We have also the funds of the international cooperation. This year in COP, for the first time, the Foreign Affairs and International Cooperation Ministry arrived at COP with a known pavilion. This is a signal because it indicates the decision of the government to increase and to engage more effort inside the cooperation. Without cooperation, it's not possible to achieve any result inside the climate change. One country alone can't solve the problem of climate change and the biggest consequences of climate change. The idea of Mattei Plan is for sure to finance a specific project, but involving other actors. The Green Climate Fund, for example, or some private sector, because only working together we can really propose a good solution. But the first actors must be the local community. We need to start from their needs, to understand what they really want in that area. And focus on this, we can use our technologies, our capabilities, our know-how to invest in this area. The program of the International Atomic Energy Agency, I spoke with Dr. Grossi about this, and we are starting also a collaboration between the Foreign Affairs Minister and the International Atomic Energy Agency on the Atoms4Food, because we believe that we use all the things that we have. They have a specific know-how in this crucial subject. As you told, normally when you say the word nuclear, you remain, wow, no, nuclear is dangerous. Nothing is dangerous. It's the use that you have that can be dangerous. If I have the car is a good instrument to move in the city, but I can use the car to kill people. And if I use my car to kill people, the problem is not the car, I am the problem. The use that I have of the car. And this is the thing of nuclear energy. Nuclear science, nuclear energy is crucial for the development of the mankind. We need to use it in a good way. And this is the picture that I recognize in the project of the International Atomic Energy Agency and Dr. Grossi, to enter in this kind of discussion, international cooperation to protect humankind against climate change, use all the technology that we have. And this is a really good technology. I am an engineer, so I studied a lot these technologies. I know the potential of this technology, not only connected to the energy sector, but it is possible to use this technology in a lot of other topics, a lot of other aspects. And it is important to prepare a good communication for this, for the acceptance, the social acceptance of this. But it's crucial to prepare people, to give them education. I am also a university professor and I have students in my class. And normally I try to send this message. We need to look the technology for the purpose that the technology has. Sometimes we can use in a bad way this technology, but this is a completely different discussion. We have very ambitious target in the Paris Agreement. We are looking for reach the 1.5 Celsius degree. The time is short. If we want really to keep this possibility, we need to use all the technologies that we have. And this one is one of the best one that we have. In other case is impossible. But to do this, the international cooperation is crucial. And when I speak about international, it's a complete international cooperation. I can give you two examples, and then I close. First one, what happened for the space science? We were able to build a space base outside of the atmosphere, where inside you can find different scientists from different countries around the world that work together for science, to have the technologies and to have the knowledge to use on Earth. The second example, one of the main discussion now of use of nuclear energy is fusion. In Europe, we have one of the biggest project, ITER, and in this project you can find European scientists, obviously Italian scientists, US, Russian, China, Korea, all together, because the only way in front of big challenges like the climate change is to answer together.
Thank you very much for giving us a very impressive message. So we are living in the era of challenges, what we discovered. And we have temperatures growing, what we would like to control it through Paris Agreement from 1.5. We have precipitation patterns change with floods, droughts. We have migration, we have social problems, also what you mentioned. But from other side of this our era, we have technologies. We have technologies what we can use. This is a huge benefit compared maybe to previous generation that need just to migrate or to die because they had no smart agriculture and had no smart solution. And the other aspect, we have technology that also can help us to cooperate and to better understand our challenges, to better understand the impact that we have all together, not only separating certain individual countries, but also to understanding how we have broader impact. And we should not be isolated under this impact because we have these technologies that we can share, what we can collaborate and cooperate through South-South or through North-South cooperation. So diversity of opportunities we have now, what we should definitely use. This is give us optimistic vision actually on what we're able to adapt to those challenges that we have now. Because the food, we know it's food, water and food is the most important part of our lives, so we cannot escape it in any way of our next generation development. And for me, as Martin mentioned, this mutation breeding also sounds like a little bit science fiction. Even I'm working in International Atomic Energy Agency and a little bit South-South cooperation for mutation breeding already like book what I can write the future. But it can be optimistic book because we have opportunities to go all together from developed countries towards a smart agriculture. And I have just several more questions and we have still a little bit of time. And I would like to maybe some kind of questions. We mentioned about smart agriculture. Yeah, it was maybe me who mentioned this smart agriculture, but I know you are more in this field. Can you a little bit give like maybe more example of smart agriculture for our auditor if someone would like to make certain examples more about this, what is meaning of the smart agriculture, or it was different examples, but maybe someone can summarize it and.
Yeah, thanks so much. Maybe I should start, but before I start, I just want to pick from what the professor and colleague from IAEA ended regarding the technology itself, Atom4Food, and of course nuclear, because we are now moving from the traditional way of agriculture, and of course at the end of the day we're going to have much productivity if the technology will be adopted across the globe. And then we also have to work towards envisaging more productivity in the developed world and as well in the developing world, because once we have this high productivity, then we will have to take over from there, which for the developed nations, they kind of have the system and processes which tend to also maintain the productivity into usage after the production. And therefore, while we are having in mind the technology and it is enhancing productivity, we should also think after the productivity towards the packaging and storage, and of course reducing the waste of that production. And this is actually the aftermath which the globe has to look into it, because we don't only have to keep on producing, but rather to use it sustainably what we are producing. And this will reduce the stress and pressure to the natural environment and ecosystems that are actually supporting curbing the climate change aspect. And this again actually links to the smart agriculture, which is quite important. What the technologies mentioned by the professor and colleague with the very best hands-on experience is actually zooming into a very smart agriculture. This is now a precise agriculture, which determines what are the requirements to the produce from the planting to watering, and of course harvesting, packaging, storage, and of course utilization at the end user, and that makes it a very important aspect. And with precise, which is what the technology will bring forth if we embrace onto it, is actually bringing on board the resources required for the produce, for a crop, for a livestock, to actually have all these requirements on board, being it fertilizer, be it water, precisely towards a very specific precision point of the produce. And instead of wasting, for instance, water resources, because we currently have the flooding, for instance, for instance, in the developing world, we flood but going smart is like having water required by amount and by time, by season, and to a specific crop. Likewise, for instance, for the diseases, if it is pesticide, then we will have now to be precise to pesticide to the crop, not the pesticide that will as well kill other species in the process of just maintaining one species, which is a crop. And because by disrupting the whole ecosystem, then we'll have again to go back and try to restore the whole ecosystem or the whole system, because we have been just dealing with one species and again impacting several other species, of which in an ecosystem they have a very huge impact. At the end of the day, as much as we're bringing on board the technology, we still also need to maintain the natural ecosystem, because at the end of the day, for instance, the pollination, not only for our crops, but there are some other plants and other systems that are actually dependent onto the whole ecosystem. So precisely linking the agriculture, the natural systems, and the technology will be the very pertinent, important aspect which we'll have to look onto it as we really embrace into the technology. But also to pick up from our colleague from Italy regarding the climate migration, because at the end of the day, the South-South cooperation or the North-South cooperation is really quite important, because at the end of the day, the impact of migration in some regions of the world, whether local or international migration, are actually impacting the whole globe, regardless of where are they coming from. We could hear from Britain debating on migrants to be taken to Rwanda, for instance, in Africa, and that's been a very hot debate. That shows that we are having a very serious impact if the technology will not be adopted across the whole globe. And I appreciate a colleague from Pakistan actually showing a very good, clear way on how we can share this knowledge, we can share the best practices, so that we reduce the pressure from the climate migration globally and of course locally, and then of course we retain our ecosystem, and maintain the 1.5 degrees Celsius before the industrial area. Thank you.
So, thank you very much for highlighting smart agriculture is a very complex system. And Martin, you would like to add something? Thank you.
Yeah. Thank you for the very good explanation of climate-smart agriculture, and I fully agree with this definition that you have just brought. and looking at agricultural and food systems from a much more holistic perspective. I just wanted to add one example of another nuclear technology, the cosmic ray sensor technology, which is a technology that can measure the moisture level in the soil. You know, water under changing climatic conditions is becoming a precious and scarce resource. And we cannot afford to waste irrigation water in agricultural systems because water is scarce and is becoming increasingly scarce. So this technology of cosmic ray sensor can help to measure the moisture content in the soil where you have just planted your crops. So what does it do? It then can inform the farmer how much irrigation is actually necessary, and to tailor the irrigation and hopefully even the drip irrigation, if you have such a system, to deploy the precise amount of water that the particular crop needs. Not to have too less or not to have too much. It's a technology that we are using in with many partners in many countries very successfully. It again sounds, you know, so sophisticated, cosmic ray sensor, right? But it's not. It's not. We should not be scared when we hear this. You know, we need to use, and the professor has said it. We cannot afford in the face of the climatic crisis. We cannot afford not to use all available technologies, and that is, let's say, from where we come in with our nuclear techniques to help farmers to adapt and to help food systems to adapt to climate change.
So, to give you also another perspective about smart agriculture, because what you listen is everything is correct. The other thing is sometimes we make an error. Think that smart agriculture is connected only to devices, some new smart devices, new technology, but sometimes it's a problem of knowledges. I try to explain. I saw a project in Mauritania that is called Half Moon. This system is extremely easy. It's not necessary anything. It is important only to learn how it is possible to use this technique. It's very easy. The problem there is that the land degradation creates a small layer on the land that reduce the capability of the land to absorb water. And when a lot of water arrives, that pass throughout, and no, it is possible to have any cultivation. So the idea is this: to create a sort of small mountain, but a mountain is like this, 20 centimeter, with an half moon for a diameter of 4 meters. Thanks to this, when the water arrives, instead of pass on the land without enough time to penetrate, they remain trapped on this border, and it is possible, thanks to the gravity, that the water percolate in the land under this layer. Under this layer, there is all the seeds that is necessary. So in the time of 2 years, 1 year and a half, it's possible to cover the desert with grass. It's easy, there is anything. It's only necessary the strength of a man that is able to put this small layer of 20 centimeters. But thanks to this, in Africa, in Mauritania, the WFP was able to restore a huge amount of land. And now this land is green with grass. The grass is able to produce food for animals, and population have the possibility to go back in this area and remain there. This is not a really smart, because there is nothing was smart, but it is a problem of knowledges.
So thank you very much. So generally we can see what smart agriculture, it's a complex of technology, knowledge, capacities under the umbrella of cooperation. If I'm mentioned everything, I would like also to pass, you would like to make a comment? No, we have half an hour still, I think. So, please.
I just, yes, of course. Okay, I am Dunya El Khouri. I am from Lebanon and founder and president of Women Organization. It's Women Association of Deir al-Ahmar. We are in a rural area in the Bekaa of Lebanon, so it's an agricultural land where we have the farmers, where we have the women, where we have the youth, and we built a center, community center for capacity building, for agro-food production, for rural tourism innovation. And I'm very happy today because we have a lot of experiences, but it's a new experience for us. Really, we appreciate, we thank you for your time and for your sharing your, and I want to mention that I'm member of the Weekend Initiative of the FAO, which is a South-South cooperation initiative regrouping women of the South countries. We are more than 200 women on this platform. And we are related to FAO in Rome, so we have a coordinator for this project, and we are collaborating together to exchange experience and to struggle together for women's right to the land, because it's crucial, because if we don't have the land, we cannot do anything. And women need the land, especially in the South countries. So I am very happy this platform could be a good platform for training. And our center in Deir al-Ahmar in the Bekaa of Lebanon is open for your, if it's possible to collaborate for capacity building for the farmers, because they are all around, and we have a very nice space to do it. So thank you so much for your for sharing, and we would like to collaborate also to learn about your experiences. I just ask about, I understand a little bit about the seeds, atoms in the seeds, but atoms in the food I didn't understand. If you can clarify, but atoms in the food or in the seeds, it's difference between both. Thank you so much, and thank you for Italy all the time supporting Lebanon and the cooperation of Italy in Lebanon. There are a lot of, perhaps we can collaborate all together to have something real and realistic and tangible for the people. Thank you so much.
Thank you very much. So, do you want to add something?
Yeah. Yeah. Thank you very much for the offer to collaborate with your center, and thank you also for being so active in a very difficult and conflict region, basically in Lebanon. And I've given you my card. We can see what kind of collaboration we can have. Atoms4Food is just a slogan that we have given to this initiative. It means nothing else than what we have tried to explain here, and that is that nuclear techniques can play a role when it comes to climate smart agriculture, to fighting against the food insecurity that farmers are confronted with. The atoms means nuclear techniques and nuclear technologies can be made available in the context of hunger, poverty, food, agriculture. Yeah? So that nuclear is not only seen as a technology that can generate power, but it has many more applications. Even when it comes to food and agriculture, you can use certain nuclear technologies. That's all that we wanted to say with this slogan, Atoms4Food.
closing remarks? No, closing remarks. Should we make closing remarks? Closing remarks.
Oh no, you can give some closing remarks. and then
Okay.
we have-
So, dear colleagues, dear also audience who is online with us and here, I would like to thank you for this impressive session that gave us a lot of ideas, a lot of message that we can take home. Thank you for your time, come here and to share your experience, because this experience is very valuable for all of us. Thank you so much and hope to see the new developments in smart agriculture. Thank you.